So, for the last year or so, whenever anyone talked about AI hardware, it was all about one thing, right? GPUs. But something kind of weird is happening in the market. A whole new chapter is unfolding, and believe it or not, it's all about memory. So, what on earth is going on? Let's dig in.
And that brings us to the big question, the real puzzle we're tackling here. I mean, NVIDIA is the undisputed king of AI. So why are investors suddenly throwing money at what a lot of people thought was the, boring side of the chip world, the companies that make storage and memory?
I mean, just look at these numbers from a recent trading week because they really tell the story. SanDisk, a company you probably know from USB drives, is up a massive 36%. Kioxia, another big name in flash memory, up 30%. And NVIDIA, actually down a couple of points. Now, this isn't just a random blip. It's a huge signal that the ground beneath the AI world is shifting.
Okay, so to really get what's going on with the market, we've got to look deeper than the stock charts. We have to peek under the hood of AI itself, because there's a hidden problem that's been growing right under our noses for a while now.
You see, that first big wave of AI, it was all about raw speed, brute force processing power. How fast can you get the answer? But as we push towards AIs that are more conversational, that can handle images and sound, the real challenge isn't just speed anymore. It's context. Can the AI actually remember what you talked about 5 minutes ago? Can it keep track of a really long, complex document? That requires a massive working memory. And this working memory, well, it actually has a technical name. It's called the KV cache. Honestly, the best way to think about it is like a series of Post-it notes. As the AI is thinking, it's constantly jotting down little notes about the conversation and its own calculations. This is absolutely crucial so it doesn't have to reread and reprocess the entire conversation from scratch every single time you ask it a new question. And here is where things get really interesting. This is the core of the problem. We have this huge mismatch. Right now, all those little Post-it notes, the KV cache, they're being stored in something called HBM, or high bandwidth memory. Now, HBM is like the GPU's ultra-elite, super-fast short-term memory. It's incredibly powerful, but it's also incredibly expensive and, crucially, very small. What we're doing right now is basically using a Formula One race car to deliver Post-it notes. It is a gigantic waste of a very precious resource.
And hey, don't just take my word for it. Listen to the guy who basically runs the entire industry. Jensen Huang, the CEO of NVIDIA. He said it himself. The bottleneck has officially shifted. It's not about pure computational speed anymore. It's about the space, the capacity to remember and manage all this context.
So you've got the industry leader himself saying, hey, this is the new bottleneck. And of course, NVIDIA comes to the table with a solution. And honestly, it's one of those ideas that's so simple, it's just genius. So check this out. On the left, that's the old way of doing things. You've got that super expensive, super fast HBM totally clogged up trying to do two jobs at once, the heavy-duty math and holding all those Post-it notes. But on the right, that's the new architecture for their upcoming Vera Rubin platform. They are literally giving the AI its own dedicated notebook, a separate, way bigger memory space designed exclusively for the KV cache. This frees up the HBM to do the one thing it's amazing at, pure computation. And the impact of this one change? It is absolutely staggering. With this new design, each GPU can now access 16 times more context memory. We're going from roughly 1 terabyte of context memory per GPU to 16 terabytes. That is a game-changing leap in an AI's ability to actually remember and reason. And making this one simple change creates this incredible domino effect of benefits. The valuable HBM is freed up to do its job. The AI gets a much, much bigger brain. The whole system becomes more power efficient. And, according to NVIDIA, this is a key part of why their next-gen systems could see up to a 5-fold total performance increase. It's a massive win all around. Okay, so this brand new architecture, it creates a huge demand for a very specific kind of memory. It needs to be big, it needs to be fast enough, and it needs to be affordable. And that's where this new kid on the block comes in, HBF. It's called High Bandwidth Flash, or HBF. And if you think of HBM as a stack of super-fast sports cars built purely for speed, then HBF is like a giant stack of cargo containers built for massive capacity. It basically uses the same NAND flash technology that's in the SSD in your computer, just stacked vertically to create huge amounts of storage in a tiny space. It is purpose-built for this new job. Now let's be super clear about something. NVIDIA's current plans don't explicitly say we are using HBF, mostly because it's not widely available just yet. But the architecture they're building is a perfect fit.
The industry is essentially designing a brand new parking spot, and HBF is the custom-built car that's going to slide into it perfectly. And you better believe companies like SK Hynix and SanDisk are racing to build it.
All right, let's tie this all together. All this tech talk, how does it connect back to those crazy stock prices we saw at the very beginning? Well, what we're seeing is this architectural shift kicking off a brand new investment supercycle.
And I gotta say, this quote from Bank of America just nails it. The first phase of the AI gold rush was all about buying the tools, the GPUs, or the shovels. This next phase, it's about building the infrastructure to handle all the gold you're digging up. It's about building massive data warehouses. And this isn't some far-off prediction. The demand for these building materials, it's already going through the roof. Analysts are forecasting absolutely huge price hikes for the exact components needed for these AI warehouses. Server DRAM prices are expected to jump as much as 60%, with enterprise SSDs right behind them. The boom is already happening. And what's so cool about this new phase is that the ecosystem of companies that stand to win gets way, way broader. It's not just the big NAND flash makers like SanDisk. You need memory controllers from companies like Marvell to act as the traffic directors for all that data. You need the super high-speed highways, the interconnects from companies like Broadcom and Astera Labs. And you absolutely need the critical power and cooling infrastructure from companies like Vertiv to keep these massive new warehouses from, melting down.
So here's the bottom line. If you are worried you missed the big AI hardware boom, think again. The semiconductor supercycle isn't over, not by a long shot. It's just expanding. It's getting bigger, and it's moving beyond just GPUs to include this whole new world of memory, storage, and infrastructure.
The first AI revolution was all about giving AI a powerful engine, a way to compute. But this new one, this is about giving AI a memory, a history, a context. It's a profound shift from building super-fast calculators to building vast, intelligent libraries. And the race to build those libraries for the AI of tomorrow, it has just begun.